The temperature T in degrees Celsius of a cooling liquid is modelled by the equation T is equal to 34 plus 68 times 0.5 to the 4T, where T is the time in minutes after the cooling begins. What was the initial temperature of the liquid? Find the temperature after 1.5 minutes. How long does it take for the temperature for the liquid to be 68 degrees C? What is the temperature does the model predict the liquid will eventually reach? So we've got T is equal to 34 plus 68 times 0.5 to the 4T. At the initial temperature, the time T, the small t that is, will be equal to 0. So we'll put 0 into this. We're going to get that T is going to be 34 plus 68 times 0.5 to the 4 times 0. Now, this will become 0.5 to the 0, and anything to the power of 0 is 1. So we're just going to have to answer 34 plus 68. So 34 plus 68 is going to give me an answer of 102 degrees C. B. When the temperature is equal to 1.5 mins, then all we need to do is substitute 1.5 in instead of small t. So we've got 34 plus 68 times 0.5 to the 4 times 1.5. Now we just need to plug these numbers in on our calculator and get an answer correct to three significant figures of 35.1 degrees C. Now part C says, how long does the temperature take to get 68? So when T is equal to 68 degrees C, we're going to have that 68 is going to be equal to 34 plus 68 times 0.5 to the 4T. Now to do this we need to really use our GDC. So going to our GDC and selecting this one, calculation mode, graphing mode, and then put in our function, which is 34 plus 68 times 0.5 to the power of 4x. We have to put it in terms of x on the calculator. Now when we press enter, nothing happens. That's because the graph is somewhere over here. We need to zoom out. So menu, window, zoom. We're going to zoom out. We're going to center here on this quadrant. Nothing happened again. Do it again, and then we start to get a graph. Just do it one more time. We start to get a graph. So we really need to set my axis now. So menu, window zoom, window settings, and set my axis to something a bit more sensible. So I'm going to go for minus 0.2 to this being 2, and my Y maximum is going to be about 110, let's say. Press OK. Now I've got a reasonable looking graph. Press escape to get rid of the center. Now I've got a reasonable looking graph. So I need to know the value when we're at 68. So Control G will bring up that, and here I need to put in Y, or T, big T is equal to 68. And that will give me that value there. Also I need to find the point of intersection. So menu, analyze the graph, number 4, intersection, and go to the left and to the right, and I get an answer of 0.25. Now on an IB question, having done it on the calculator, you would be expected to draw a graph. So just a sketch of the graph. Okay, make sure you label the axis small t and big T. Draw the graph and label it. Draw on the other one, which is T is equal to 68. Mark on the point of intersection and reading off here. Now this is 0.25 minutes. So quarter of a minute, which is equal to 15 seconds. D, we want to know what the temperature the model will eventually predict, and that's always going to be this number here, 34, because at that particular point, 34, this will be what's known as a horizontal asymptote, and the temperature will get closer and closer to 34, but never actually equal to it. So T will be equal to 34, will be the horizontal asymptote. So the last part will be T is equal to 34 degrees C. The liquid eventually will reach a temperature of 34 degrees C.